Anyone has any doubts in constructor inheritance or method overriding or the usage of final classes? We'll just take a couple of minutes if anyone has any doubts, or we'll get started with today's topic. Okay, we'll get started with today's topic, that is abstract classes and interfaces. So, as of now, we have seen several object oriented principles, and we had seen object oriented principles like encapsulation, and then we saw object oriented principle such as polymorphism using the compile time polymorphism and the runtime polymorphism, and we'll further go ahead and see abstraction as well. So abstraction is another uh, object oriented principle which is basically like hiding the implementation details. For example, you know how to drive a car, but you don't know the dynamics of how basically a car engine works, or like the internal mechanism in which the car has been like designed. So that is known by the designer. So you basically know how to drive a car. What that means is you're not concerned with how the engine or the fluid, how the combustion is basically happening in a car, but you are more concerned about how how the driving works, how the accelerator works, how the brake works, how the clutch works. So basically that is the thing, means whatever the complexities or the implementation details or the complexities which are there in the designing of a system, that if you can hide that and just give the functionality to the user, so that is basically like abstraction. So it's the process of basically hiding down the implementation details and showing only the functionality to the user. So that indicates that only the important things to the user are known and the internal details are not known. So basically we don't want the user to get concerned with the implementation details, and so only the relevant details or the functionalities to the user. So that is basically abstraction. So using a car was one of the examples. Similarly, there can be like uh, lots of different examples as well, such as like while sending SMS you just type the text and send the message. Here you do not basically care how the internal processing of the message delivery, so how that message got delivered, which all networks are basically involved, how the message is getting delivered from a network to some uh, user. So that is not your concern. Your concern is basically you send a message using an SMS and it gets delivered to your friend. So that is the main concern. So this entire phenomena is basically called abstraction. And this there will be certain use cases where you will basically have to use these oriented principles. So while developing any project, so there will be scenarios where you will try to implement a functionality in different ways, and you would like to keep certain implementation details hidden from the user. So those things can be basically achieved using abstract classes, and abstract methods. So basically what an abstract class is, abstract class is basically in Java, if a class has some abstract methods or can have some abstract methods, so we can call that class as an abstract class. So let's say we mark a class as abstract. That means that particular class can have some abstract methods and some concrete methods. So there are two terminologies here: abstract methods and concrete methods. So concrete methods are the methods which I had been creating as of now. So you saw certain things like whenever we created any method and provided the definition, provided the implementation of that method. So that method is basically called a concrete method. That is, the implementation of that method has been done in the class. But when I talk about any abstract method, so that means that we do not provide the implementation of that method in the class. We just provide the method signature or the prototype, you can say. It's just like providing the uh, uh, method signature. Like you have your return type, method name, the parameters followed by semicolon. I will show you that in a demo how we basically write down that. But the entire use case is basically hiding the complexities of designing a system from the user and just letting the user know the functionality. So this is basically achieved by abstraction, and in Java we basically use abstract class and abstract methods to achieve this. So let's say abstract methods do not have an implementation. It only has method signature. So this is one of the rules of abstract method. Another rule is if a class is using an abstract method, they must be declared abstract. So suppose in a class you have one of the abstract methods. So it is mandatory to mark that class as abstract. But suppose you have any class marked as abstract, you can have some abstract methods or you cannot have some abstract methods. That is up to you. But generally, on the design principle, the expectation is when you have some classes abstract, that is basically meant for having any abstract method in that particular class. And that abstract class can have some concrete methods as well. That means that an abstract class can be like it has some methods which has implementation details and some methods which are basically abstract. It can also have all the methods as abstract. So that is that is how an abstract class will be designed. And any class which basically extends from the abstract class, suppose there is some child class which is extending from the abstract class or inheriting from the abstract class, then that class must implement all the abstract methods. Suppose an abstract class has some abstract method whose implementation details were not provided, then there is some child class which inherits or extends that parent class. So that class has to implement that method, provide the implementation of that abstract method. Or even if that class does not provide the implementation detail, then we will have to mark that child class as well as abstract. And then whichever class subclass inherits from the child class, then that particular class has to provide the implementation details of the that particular method. So somewhere down the line, one of the subclasses has to provide the implementation detail of that particular abstract method. And if any class has any abstract method, so it's a mandatory or it's definite that we will mark that class as abstract. And also one thing, there's one rule: we will not create any object of an abstract class. We will not create an object of an abstract class. So these are the things. So Let's go to another slide. We'll go through, we'll take demo exercises to demonstrate this, then it will be like more clear. But this is the entire use case which will be covered using this object oriented principle. Let's see now what is basically abstraction and encapsulation. So abstraction is solving the issues at the design level. So it solves the issues at the design level, and the functionality is only known to the user. So encapsulation solves it at the implementation detail. Suppose, what is abstraction here? Abstraction is like creating a prototype or a method signature. And then encapsulation. What is basically encapsulation? It shows the implementation of that particular method. So that is how you basically demonstrate encapsulation. And another point, abstraction is about hiding unwanted details while showing most essential information. It's again the same thing. It's like showing the functionalities to the user, and whatever the internal design details are there, that is hidden from the user. Now, what is encapsulation? Encapsulation means hiding the code and data in a single unit. So you have a class. You have a class. A class has certain states and behaviors. So states are also basically attributes or your data members, and behaviors are basically the methods which are defined in that particular class, and the entire behavior or the states are basically logically clubbed and grouped into a single piece of code that we basically called as class. So we can say that the code is in a single unit. The behavior and state has been binded into a single unit, and we further bind these classes into some package. So this is kind of like binding the code into a single unit. So this is basically called abstract encapsulation. Another point is abstraction allows focusing on what the information object must contain. So encapsulation means hiding the internal details or mechanics of how an object does something for security reasons. So abstraction basically allows focusing on what the information object must contain, which the user must know. So that is the main focus of abstraction. And encapsulation is basically hiding the implementation or internal details for security reasons, because we have created some class which must be like the internal methods or the behavior of that particular class or that particular code must be hidden from the user for some security reason. So at implementation level, that is called encapsulation. So these are the basic differences between abstraction and encapsulation. Okay, we'll see how we basically create an abstract class. So when we create any class as abstract, we basically mark that class as abstract. So as of now, you have been creating classes using the keyword like public class, class name, and then followed by parenthesis. And also sometimes you have created classes like class bank account. Depending upon when you create a class with class bank account, that is a default class. And when you mark the class as public class bank account, that class is basically public. So that we have, these things we have covered while we were going through access modifiers. So but when you mark that class as abstract, when you mark that class as abstract, then this class may or may not contain some abstract methods. It can have some abstract methods, it can have some concrete methods as well. So, an extremely useful feature of object oriented programming is the concept of abstract class. Using abstract class, we can declare classes that define only part of the implementation, leaving subclasses to provide specific implementation to some or all of the methods. So the common behaviors of the subclasses can be declared in an abstract class, while behavior which makes sense only in subclass and not in generalized superclass should be declared abstract in superclass. Say, in a hierarchical organization, what can happen is in a department, in a department, there are some functionalities which are like common to all the employees. So what we can basically do, let's say some department, let's say uh, computer engineering department. So we have some functionalities which are like common in that particular department. So and then if we further subdivide that computer engineering department into two, let's say there is some computer engineering department, let's say computer engineering department is divided into CS and IT. And what happens, whatever the common functionalities for CS and IT are there, so we can declare that particular thing in computer engineering department. And there might be some functionalities, similar functionalities in CS and IT, but they are like implemented in a different way. Like those functionalities might be a bit different. So those functionalities will be implemented in the subclasses. We'll see how we basically achieve that. So the common behaviors of the subclasses can be declared in the superclass or the parent class, while behavior which makes sense only in subclass should be created in the child class. So subclass must contain, suppose one of the subclass has some method which does not make sense for the other subclass. So those methods should not be declared in the superclass. Why? Because whatever superclass has any method, so that particular method is automatically inherited by the child class. This we have already seen using the concept of inheritance, right? So whatever attributes or behaviors or whatever variables or methods the parent class has, the child class automatically inherits those methods or variables. So we have seen this while we were using inheritance. So similarly, while using an abstract class, we will basically keep the common functionalities in the superclass, and the functionalities which are different for the subclasses should be should be implemented at the subclass level. So what if superclass does not have stand and valid reason to get instantiated? So you can mark a class as abstract. So there might be certain scenarios where you do not want to basically create an object of the class. So in such case, you can mark that particular class as abstract. So when you mark a class as abstract, that means that we cannot create the object of that particular class. So this way you can create a class that cannot have objects but serves as a basis for extension by other subclasses. So we'll see this with a example now. Let's go to our editor. We'll create some, I'll create a new package. Let's say I've created one package as com.java.training.abstraction, and let me close these previous tabs. And let's say I create a bank account class. Now what happens, there can be different type of bank accounts, right? We can have a savings bank, we can have a loan account bank, we can have a current bank account. So there can be like different types of bank accounts: savings bank account, bank account, and then current bank account. So the let's say the interest rates of each of those banks are different. The interest rates of each of those banks are different. So we cannot create that compute interest method in that particular super class, right? So suppose, let's say, let me create that bank account class and then I'll show you bank account. Let's say we have some ID over here. I marked it as private. Now let's say I have some balance. Let's mark this. Okay, let's mark this as protected. Let's say I want to create the constructor now. We'll go and click on this generate. We'll click on constructor. We'll click both these parameters and then we'll generate this parameterized constructor. These things we have already seen. So now let's say I want to make this class as abstract. So when I want to make this class as abstract, let's say I mark this class as abstract. Okay, before making this class as abstract, let me show you one thing. If I have some method such as float float compute interest rate. So we have some logic in this particular method to calculate the interest rate. Return, suppose 0.01 into, let's say, balance. This dot balance. Now, okay, float double. Okay, okay. Now let's create one child class. We'll create one child class. Let's create one child class as saving account, which extends from this bank account class. So this will tell me, see, when I created this class, right, I started getting some a message that create constructor matching super. There is no default constructor available in the bank account constructor. So we'll go ahead and create constructor matching super. So what this basically means, we have seen this yesterday, right? So using this particular constructor, we can call the parent class constructor. We have already seen this, right? We were passing super with the parameters. So whatever the parameters are there, one integer id parameter and one float balance parameter, so we will basically pass this. Okay, one second. Else current balance extends. There was some issue, there was a wrong import. Okay, now this is correct. So see, This class has a constructor which has id and balance, and then this class has another constructor which takes one id balance, and we can pass these parameters to the parent constructor, parent class constructor, such that it calls this. Everyone is aware of this, right? We had seen this uh, example yesterday, where we can basically use super to call the parent class constructor. So let's say we have some, we have a method now, and that method is basically again float compute interest. So we'll create this same method again here, and we have again some logic, return balance into, let's say, 10 dot 0 f into balance. See, what this does now is we have the same method here and we have the same method here. Does this make sense? Does this make sense to keep the same method here and here as well? It does not, right? See, a bank account is kind of like a generic bank account. So there are like different categories of a bank account, and each bank account will have its own rate of interest. So what we can basically do, suppose we have different child classes. Let's go ahead and create another child class. Let's go ahead and try to create current account, and this will also extends from bank account. So let's go ahead and create its constructor such that we can pass the parameters to the parent class. Now let's say this also has this same compute rate of interest. See, and this has some different, something like 12.0 f into balance compute rate of computer interest rate. So it should be like 0.12 f, something like this, and the compute rate of interest is computed something like this. So what happens, see, these are the child classes of the bank account class, and these have their own implementation of the interest rate computation. So if such is the case, we do not want this parent class to actually provide the implementation, because none of the child classes are basically using this particular method. Agree, right? None of the child classes are using this method. So it is very logical that we go ahead and mark this class, this particular method as abstract. So what we'll do is, what we'll basically do is remove this implementation. When we want to remove this implementation, remove this curly braces, provide a semicolon at the end, and then mark this method as abstract. Now when you have like marked this method as abstract, you will get some warning. What warning you will basically get is, if any class has any abstract method, if any class has an abstract method, that class must be like marked as an abstract class. So see, as of now this class has been marked as a public class. we will have to make this class as an abstract class. Why? Because we have one of the methods which is abstract. Abstract, that means we have not provided any implementation details of that particular method. So this is abstract method, that is only method signature and no implementation details. And class is abstract since we have an abstract method defined. And now in savings bank account and current bank account, we basically have methods which will have the implementation of this compute rate interest, and it will means there is some calculations. Basically you take this balance, and using this balance you will be multiplying with some number, and okay, I multiplied it two times. Let's go ahead and remove this. I've done it here as well. So let's say we have computed the interest rate, and we are using this return keyword to return the value. So whatever is the value we are basically returning. So this method returns us some float value. So now let's go ahead and see how we can basically create a object of the child class. So let's go ahead and create a test class. Let's go ahead and create a object. So now this object will ask for some parameters. So what parameter? Okay, one second. New saving bank account. So we have created this object. So this will ask for two arguments. Why it will ask for two arguments? See, we could have also created a constructor, an object without any parameters, right? Remember there was a default constructor, but in this class we have not defined any default constructor or no argument constructor. So what happens now when we go ahead and create an object? It will definitely look for parameters because we have not defined any default constructor. If we had created any default constructor, then it was fine that we created a object without passing any parameters. But now we'll have to pass the parameters. And what parameters will basically pass? We'll pass id, and then we'll pass balance. Let's say id is 1. Let's say balance is uh, 3000. And what we can basically do, see, we cannot create the object of the abstract class. Bank account is an abstract class now. But what we can do now, we can create a reference. We can create a reference of the bank account class. Reference of abstract class is assigned an object of child class. And let's say we are using this bank account dot compute interest rate, and we are trying to print this. Let's run this program. So based on the calculation, there is means we got this result. Actually, the rate of interest won't be something like this. Let's modify this something like this. Let's say the rate of interest is 9%. So what we basically did, we created an object of the child class in which the implementation of that particular abstract method was done, and we used the reference of the parent class. We could also have done it this way. We could also have done this way. That would also work. Savings account, saving account, saving account dot. Okay, saving account. So let me go ahead and comment this out. See, now when I run this, right, if I run this, this also gives me proper result, and it gives me the same result, interest rate, right? That is 9%. We had already seen this. See, this is this is one method which is defined in the child class. So in the test class, we are going and creating the object of this particular class, and we are calling using this object. This is one way, but you can also use the parent class reference even if the abstract class object cannot be created. What you mean by basically object? But object is only this part, new savings account and the parameters. This is the object part. This is basically the object part. So this gives you the object, and this is basically the object reference. So object reference can be of the abstract class, but the object cannot be created for the abstract class. So this is one way. So if we try to like create an object of the bank account obj new bank account, see, we'll start getting error, and it will try to ask us to provide the implementation details. We'll start getting error. It will ask to provide the implementation details. Why? Because the bank account class is an abstract class. It has one method whose definition or the implementation is not provided in bank account class. We provided the implementation of this method only in the child class. So we cannot create the object of this bank account class. We can create the objects of the child class, saving account and current account, which is basically providing the implementation of this abstract method. So we can create the object and also use the object reference of the child class, and also we can use the object reference of the parent class. So similarly, we can also go ahead and create a current account current account, current account dot compute rate of interest. Let's say the ID is 2 and let's say the balance is 4000 F. So this time we are basically creating the object of the current account and we are using the reference of the abstract class. Let's go ahead and run this. So the first two examples are basically calling the method of the savings account, and the third time, since the object is basically created of the current account class, so the method compute interest rate will be basically called from current account. So this particular method is called in the third invocation. So just check this program, just go through this program once and let me know if you have any questions. Hope this is clear for everyone, this particular example of abstract class. So let's go to the slide once. So we have seen this example. We have demonstrated this example using the editor. So when we basically use abstract methods in abstract class, abstract methods are mostly declared when two or more subclasses are also doing the same thing in different ways through different implementations. It also extends the same abstract class and offers different implementation of the abstract methods. So the subclasses are basically providing the implementation of the abstract method which is defined in the superclass in a different manner. So we basically have the implementation of the same method, but the implementation or the logic that is provided in that method is basically a bit different, or it can be totally different as well. So this is the main point of this. So abstract classes help to describe generic type of behaviors and object oriented programming class hierarchy. It also describes subclass to offer implementation details of the abstract class. So this we have seen using the example of the bank account, which was an abstract class, and there were two child classes, that was savings account and current bank account. So this is how we basically achieve object oriented principle of abstraction using abstract methods and abstract class. Now there is another topic which is basically called interfaces. So in Java basically we have another concept which is interfaces. So when do we basically use interfaces? So interface is basically used when all the methods are basically abstract. Suppose you have some use case where you basically have all the methods as abstract. Suppose in abstract class we have seen that as we can create some methods which can have some implementation as well. Suppose this class is abstract, right? Let's go ahead and try to create one print method, and let's go ahead and try to print something. Let's say we print hello world here. So we created this, and then we went ahead and current account dot print. Let's execute this program. So we are able to print hello world. See, there's one thing, right? We had bank account class which was marked as abstract. So, and we had one abstract method, and this method, this public void print, this is concrete method. Concrete method means a method, a method with implementation provided. So this is a concrete method. But when we go for interfaces, then the use case is that all the methods in an interface will be basically abstract. That is, no implementation of the methods will be provided. There is some exception to this in Java 8, where we have the concept of like default and static methods. But let's go with the general thing now, that in an interface basically all the methods will be abstract. So we will not be providing any implementation detail of that particular method. So that is why we basically use interface. So an interface is a way to declare a type consisting of only of abstract methods and related constants, enabling any implementation to be written for those methods. An interface provides a protocol binding to the classes that implement it. So we basically define the prototype or the protocol in the interface, and any class which basically implements these interfaces will be basically providing the implementation of that particular methods. So an interface can never be instantiated, that is, and we cannot create the object of an interface. It is similar to an abstract class. For an abstract class also we were not able to create the object. Similarly, we won't be able to create the object of the interface as well. But what we can basically do, we can use the reference of the interface. We can use the interface reference to assign a object of the class which is basically implementing this particular method. So there are two rules: variables and methods. So whenever we have some variables in the interface, they will be by default public, static and final. See this example, we have this interface graphic, right? We have this interface graphic. So there's a variable float pi whose value is 3.14f. See, we have not used any keyword as such public, static, final, but by default this pi variable is public, static and final. Even if we do not use any public, static, final before this data type, it is by default public, static and final. And similarly for methods we have not defined anything like public or abstract, but by default this float area method or float periphery method, these are by default public and abstract. Why? Because these methods are abstract, because the implementation has to be provided by some of the classes which basically go ahead and implement this interface. So that is why these methods are by default public and abstract. So every member of an interface is always public, whether explicitly specified or not. The variables declared are always static and final, and the methods declared are always abstract, though explicitly not specified. On compilation, interfaces are converted into .class file. So means this is like compilation process. If you compile, we had seen in our first or second class, right? When you compile a class, it basically creates your .class file with that byte code and all. So this is an interface. We'll basically see the example of interface. Let's go ahead and try to like create one package when and we'll show the demo of interfaces. Let's create one package com.java.training.interfaces. Let's go ahead and try to create a see when I go ahead and try to create a new Java class, right? I get many options like class, interface, enum, and annotation. As of now, I was just selecting this class every time. Now I want to create an interface. So when I want to basically create an interface, what I will do, I will go ahead and select this interface. So let me go ahead and select this interface, and I will provide some name. Let me provide the name, say graphic. So I'll take the same example. Let me provide the interface name as graphic, and what I will basically do, I will go ahead and I will create some uh, float by constant is equal to 3.14f. So this variable is by default public, static, and final. And let me define some abstract methods. So even though I don't mark these methods as abstract, so this will be abstract. See, there was one difference in abstract classes. We have to mark those methods as abstract, right? Remember, we had marked those methods as abstract in the bank account class, that compute interest rate method. We had marked that method as abstract in the abstract class. But here we don't want to explicitly mention it as abstract. By default, this is known that this method is public abstract by default, and this variable is public static final by default. So let's go ahead and try to create another method. This is for calculating the perimeter of some of the rectangular surfaces. Let's say we have some rectangular surfaces like circle, square, or rectangle, s- and we'll try to like create use some kind of formula to compute the area or the perimeter of those rectangle or the or some perimeter or area of those graphical figures. So what we'll basically do, we will create some class which provides the implementation of these particular methods. So let's create one class called circle. Let's create one class called circle. So see, when we were using abstract class or parent child relationship, what we were basically using, we were using the keyword extends. Remember, we were using the word extends. So when we when a child class basically inherits something from a parent class or an abstract class, we basically use a keyword extends. So this is like showing parent child relationship between classes. So for that purpose we will use the keyword extends. But this is interface now. This is interface where we have all abstract methods, and when any class wants to basically provide the implementation of these particular methods, we will basically go ahead and use the keyword implements. And what we will basically implement, we will use the name of the interface. So in classes basically we were using the name of the superclass, remember. Here what we'll basically do, here we'll go ahead and use the name of the interface. So see, once we write down this implements graphic, right, you start getting some you start getting some suggestion from the editor that implement methods. So basically your interface had some methods which were not provided the implementation. So now that this particular class implements the interface, this class has to provide the implementation for those methods. So we'll go ahead and click on this implement methods. Okay, let me try to create one of the methods like float area. So this is one thing. Or what you can basically do, there's one simple thing, you can go ahead and try to click on this implement methods. So when you basically go ahead and try to click on this implement methods, this error will go away. This error will go away, and basically this override, you see this thing, right? So whatever method signatures you have provided here, this will be always be provided with this at the rate override. So you will have to now provide some kind of method definition here. You will have to provide the implementation details here in this method. See, these were the two methods, area and periphery. So we had not provided any implementation here, and this particular class circle basically implements this interface. So these two methods have to provide the implementation both this for both the methods which were defined in this graphic interface. Let's say we go ahead and create one constructor. We create one constructor of this circle class, public circle. And let's say what properties circle has. Circle has basically a radius, right? So let's say the circle has some kind of radius, and let's say we are this dot radius equal to radius. We are basically initializing the data member, right? This we have seen while we were using constructors. This is our data member. This constructor is a parameterized constructor. It takes one of the parameters, and we are basically initializing our radius parameter. Now what we'll basically do, there is some formula for creating the area of a circle. So it's basically using like pi into radius. Don't go into the complexity if you don't remember the formula to calculate the area. There's not much of need, but see, this is the a method, pi into radius. So see, this pi variable was basically defined in the interface, and this circle is basically implementing it, this interface. and this variable is public, static, and final. What this means is this variable is public, so this is available everywhere in all the packages, in all the classes, and this value is basically final. So what that means is the value of pi cannot be changed as well. So what we are basically doing, we are using it to calculate the area of the circle, and we'll also go ahead and calculate the area of this, calculate the perimeter of this circle. So it will be 2 into pi into radius. Do not get worried about these formulas. It is a geometrical formula to calculate the area and perimeter of the circle. So similarly, we can have another graphical figure as well. Let's say there is another class which basically goes ahead, and so this also implements graphic. So see, again we get this error. To implement the methods, we'll go ahead and click on this implement methods. So it will create some, it will provide the definition for, it will create a method structure for me when I click on that. Now let me go ahead and create a constructor. So basically the rectangle has a length and breadth. So let's say rectangle has length and width. So we will go ahead and again click on generate constructors and try to generate a constructor with length and width. So see, we have two variables here defined as instance variables, and this parameterized constructor is basically taking two parameters and initializing the data members. So here we have provided that the initialization of the data members using constructors, and now we will use these two methods that we had, that had the signature defined in graphic interface. Since we are implementing this graphic interface, we will basically have to provide the implementation of this. And what this means is, what will be the area will be basically this dot length into this dot width. So basically if you multiplied the length and width of a rectangle, you will get the area. And how you basically calculate the perimeter is, you basically use this formula. It is 2 into width plus length. Okay, so now that we had provided the implementation of both the abstract methods in the class circle and rectangle, we'll go ahead and try to create a test class and try to see the output of this. So remember one thing, we cannot create the, we cannot create the object of the interface. If you do something like this, new graphic, it will ask you to again create this, it will ask you to basically create an anonymous class. So we cannot create the object of the interface. See, graphic is abstract, cannot be instantiated. So I'll just copy this. So this will throw you an error. What you can basically do, what you can basically do is use graphic keyword, use the reference, and then try to create the object of some of the child classes or of the classes which were basically implementing. So let's say we created an object of the circle. So this basically requires one parameter, and that is radius. So let's go ahead and pass the radius as 7.5. Okay, 7.5 f, and we are using graph. Okay, one second. So graphic dot area. So let's go ahead and try to run this. See, we got the area of circle. We can write down some comments over here. Area of circle, graphic dot area. Similarly, let's go ahead and try to create a, also let's go ahead and try to like print out periphery of circumference or perimeter, circumference of circle, circumference of circle, graphic dot periphery, and we'll do similarly for rectangle. We'll do similarly for rectangle, where we were basically asked to provide length and width of the rectangle. So area of rectangle would be basically rectangle dot area, and perimeter of rectangle would be rectangle dot periphery. Let me try to run this program. See, area of circle is given, circumference of circle is printed out, area of rectangle is printed, and similarly perimeter of rectangle is printed. See, what we basically did, we cannot create the object of interface. Why? Because interface is abstract, and interface is having like all the methods are subtract, so we cannot create the object of an interface. What we can basically do, we can have an object, we can have interface reference, and the class which is implementing those particular abstract methods, we can create the object of that particular class. So we similarly created the object of circle, and what this basically did, this when we created an object, this called the constructor of circle class, and it initialized this data member. Now our circle class has basically, our data member has the radius, right? And using this radius, we had used the area and the periphery methods to return us some value. Basically, this method is calculating the area of circle. This method is calculating the periference or circumference of the circle. And similarly, we had done the same in rectangle. We had taken length and width as the parameters of rectangle, and we had created a constructor, created an object of rectangle and passed two values, which went ahead and called the constructor of rectangle. So similarly, we were calling both the methods now rectangle dot area and rectangle dot periphery. So we are able to call all the methods using this. Is it clear to everyone? Anyone has any doubts? Please let me know. Okay. If there are no doubts, we'll move ahead. Okay. So we have seen this, how we can basically create an interface and how the class implementing those interfaces can provide the definition. So we basically use the keyword implements. This is the keyword implements that we basically use to implement any interface in a class, and we have to provide the definition of those abstract methods. So this area and periphery methods were abstract in the interface. Here we have provided the implementation details. So now see, we know that if there are two classes, one class can extend other class. So similarly, if there are like two interfaces, can they do the same? So we'll see this. See, an interface can extend one or more interfaces by using the extend keyword. However, an interface cannot implement another interface and class cannot extend an interface. So when I say something, see, this class, if there is a class called rectangle, it cannot extend an interface. This will always implement an interface. So remember this difference. If you start, if you go ahead and try to use something like this, extends graphic, you will get an error. Why you will get an error is basically graphic is an interface, and an interface can always be implemented using a class. So a class can only implement it. But what happens now? Say there are like two interfaces. There are two interfaces. And what we basically want to do is, so we want to see if one interface can basically mimic the behavior of another interface. So what is possible in Java is like an interface can extend another interface. We'll go ahead and see. Interface will create another package com.java.training interfaces inheritance. Let's say we create one interface, and this interface is basically called, let's say this interface name is basically called um, animal, and let's say we name something like can run, and we have another method, let's say this is run, and then we have another method where we have something called eat. So animals can basically run, animals can eat. Let's say I go ahead and try to create another interface, birds. So what I want is basically, let's say bird can also run and bird can also eat. So what I will basically do is, but I want to like reuse these two methods since this interface has already these two methods, right? What I want is I would create another method like void fly, and what I'll basically do, I want these two methods run and eat also to be available in bird interface. So what I can do, I can use the keyword extends and I can use animal. So what this means is these two methods that we have, these two methods that we have in animal are also available in the interface bird, are also available in the interface bird. Now what I can do, if I go ahead and try to create a Java class, if I want to create a Java class, let's say, let's say I create some class called birds world, and what this basically does, it implements bird interface. It implements bird interface. So if I go ahead and try to implement these methods, if I go ahead and try to implement these methods, see what it basically did. It created three methods for me. It created three method definitions for me. See, how many methods did we provide here? We provided only one method here. But since this interface is extending animal interface, so this by the process of inheritance, by the process of inheritance, these two methods are also available to this bird interface. And when I create this birds world, so what so all these three methods are available to me in this class. Why? Because this class implements the bird interface. So I'll just go and print out something. Let's say birds can run, birds can eat, and birds can fly. Now I will create a class, let's say test class, and what I will basically do, I will create the reference of the bird interface, and what I will basically do, bird dot, okay, bird dot eat, bird dot run, and bird dot fly. Let me go ahead and try to run this. So you see, right, we get this output: birds can eat, birds can run, birds can fly. So this is the concept of inheritance using interfaces. So earlier in previous classes, 2 3 classes, right, we had seen how a class can basically implement interface using the extends keyword. So if there is a parent class and if there is a child class, so basically we can show the relationship of inheritance using the keyword extends. So similarly in interfaces also we basically can show the relationship of inheritance using the extends keyword. So if you say this extends animal, right? So what happens? This particular interface has all the methods available in the animal interface. Also, you can one more thing. This you know now that the class implements the interface. So if you had some another class as well here, if you had some another uh, class here as well, let's say you have some class as um, you have birds, then you have animals, let's say you have some predators. There's a class called predators, and if there is some method public void uh, public void kill other animals, something like this, something like this. I've just provided some method definition. So if there is a bird's world, right, and you want to do something like this, it can extend predators and implements bird at the same time. See this thing means it can extend another class and implement another interface as well. Anyone has any issues in this syntax? This predators is a class, this birds world is a class. So earlier we had seen a class can extend another class and a class can implement an interface. Here in this syntax we are basically writing it all this together. So a class is basically extending another class through inheritance as well, and this class is implementing this particular interface as well. So this also can be done. So similarly, if there was like another class as well, right? Sorry, if there is like another interface as well, so it can be done like implements bird comma another interface means if suppose there was like another interface, so it could be done something like abc. If there was like another interface, we can do something, an interface can extend two interfaces as well like this. So this can also be done. So just see for this example, this class is extending another class and implementing another interface. Is it clear for everyone? If you have any questions, you can ask me. So we saw two concepts today, right? One is like abstract class and one is interface. And abstract classes basically had some concrete methods and some abstract methods. And the child class, which was basically extending from that abstract class, had to provide the implementation details. And while using interface, all the methods which were defined in the interface were basically abstract, and whatever class implements those particular interfaces has to provide the implementation of those particular methods. So this was done using interface. And we also saw one thing, like there is the concept of inheritance as well, using interfaces. So an interface can basically inherit another interface as well using the keyword extends. So that is also possible. Okay, let me go to the slides. So we had seen this extending interfaces, right? One interface drawable graphic extends another interface. So we had seen this while using the bird and animal interface example. And I'll also show you one example which is like very important and which is also like interview question. So sometimes there's a concept of like um, inheritance using multiple inheritance. I'll show you one means this is an interview question. This is very important. So there is some kind of concept called multiple inheritance. So let me try to go ahead and create another package inheritance dot multiple. This is a very important interview question. Just focus on this. So see, when I say that I have some Java class and I have some Java class where, let's say, I'll just try to create some demo classes and I'll show you what multiple inheritance is. Let's say we have some class called A, then we have some class called B, and both these classes have some method called void void print, and this also has one method as print. So these are two separate classes which has the same method like void print. Now what I basically do, I go ahead and create another class C which tries to extend A comma B. So see, we automatically started getting error. Class cannot extend multiple classes. Means what will be the issue? What will be the issue when I do something like this? Let's go ahead and try to create a, means already we are getting error, but let's try to understand this. So if I create a object of this C class, right? See what happens now if I do something like C dot print. Understand this concept, right? When I create this new dot new C, since this is, if this class was able to inherit both A and B, if this class was able to inherit both A and B, right, and both have the same method, both have the same print method, the Java compiler will definitely get confused, right? At line number 7, when I do C dot print, when I do this C dot print, the Java compiler is basically confused which print method to call, whether the print method from class B or the print method from class A. Got it? So this is a confusion, and that is why Java has unsupported multiple inheritance. So unsupported multiple inheritance. So you cannot inherit from multiple classes in Java. So unsupported multiple inheritance through class. But there is one way that you can still go ahead and try to achieve this multiple inheritance. So that is using the interfaces, so since this class will give me error, See, unsupported multiple inheritance through class. When you will see this code commented, right, you will recall that there was a reason why Java had not supported multiple inheritance. Why? Because Java compiler might get confused. Like, I want to call the print method from which class, whether from class A or from class B. So there will always be some kind of confusion over there. So that's why this will give me error. Now let's see how we can achieve this. We can achieve this using a using interfaces. So I'll go ahead and try to create com another package com.java training inheritance multiple interfaces. So I will close all this, and what I will do, I'll try to create one interface. I'll just name it as A, and let's create another interface. Let's name that interface as B, and I will create one class. I will create one class C which will try to like implement both this A and B interfaces. Now let's see, we have we have some default method. As of now, as of now you I had told you that interfaces can have only abstract methods, that we do not provide the definition of those methods in the interfaces. But there is one exception. You can create a default method in interfaces, and that method has to have this keyword default. So I'll write down creating default methods. So you have to use this keyword default. You have to use this, you can use any data type. So let me just try to use void print, and let me try to use just print out something like hello world, and I will create a similar another method, another default method in this interface. Let's say welcome to Java training. Everyone please focus this here. This is important, and this is an interview question. So now what I will do, I will I will do something like this: implements a comma b. So I will have to implement the methods. So what Java does is it gives me a suggestion automatically. You can call the method of this interface. See, you can do something like a.super.print. When you do something like a.super.print, what it will basically do, it will go ahead and try to call this particular method. Let me try to create a main method, and let me try to create an object of this child of this C class. Let me try to run this now. See, we are able to print this, right? We are able to print hello world. This is achievable using multiple inheritance. Multiple inheritance supported using interfaces. See, multiple inheritance was not allowed using Java classes because the compiler would get confused that this particular method I need to call from which parent class. So that was the confusion, and that is why Java has not supported multiple inheritance using classes. But sometimes you might have some use cases where you want to implement that. So that can be achieved using interfaces. So what you can do, you can basically create two interfaces and you have the same method, create one default method in the interface, create the same default method and provide some different implementation details. And in another class, basically you can do this implements a comma b. See, here this was not allowed. C extends a comma b was not allowed. But here using this is allowed. Like we can implement two interfaces. So we are implementing two interfaces, and what we are basically doing, we are doing a dot super dot print. So let's do this as well. Let's do b dot super dot print. So when we do this b dot super dot print, it will basically print this method. It will print this method. See, we are able to print this. Welcome to Java training and hello world. So this is the concept of multiple inheritance which can be achieved using interface. So this is an important interview question. Go through these ones. If you have any confusion, you can ask me. So we'll conclude the today's class here itself. So we'll get ahead with the next module in the next class. So I'll upload this recording of today's video, and also I'll share the demo exercises by end of day today or by tomorrow. So if you have any confusion, you can ask me now or go through the content and try to understand. If you still have any issues, you can ask me in the next class. Let me stop sharing and I'll also stop the recording.
Recording stopped.